grade 9 mathematics. And of course, my name is Hendrik Makaneta. If you want to reach me, you can reach me on Twitter account at Hendrik Makane3. And of course, as I've already indicated, that we are going to look at the minimum conditions for similar triangles, but also to solve sides that are not given. Yesterday, we looked at this example here, which formed the basis for our similar triangles, and we spoke at length about the proportional manner in which you need to increase your original base there, which is the D, and we also spoke about A and B. But of course, of importance, we said that two triangles are similar. They've got the same shape, but different size. So that is what we spoke about yesterday. And of course, we solved quite a number of problems. You will recall the first one there. This is what we solved initially. And of course, we also looked at the bigger triangle and the smaller triangle, which is PQR and ABC. We were able to conclude that triangle ABC is similar to triangle PRQ. You'll realize that I'm moving faster because these slides that I'm showing you are yesterday's slides, and I'm going to zoom directly now just to recap, and I'm going to zoom directly into today's lesson. And of importance, we also agree that if two triangles are similar, then all pairs of corresponding angles must be equal. Equally, all pairs of corresponding sides must be in the same proportion. So those are the conditions for similar triangles. And of course, I'm not going to waste time. I'm going to proceed now to look at the homework which I gave you. Let us first mark this homework which I gave to you yesterday. And of course, looking at the first one, we've got 1, A and B there. You are given a pair of triangles. All that you need to do is to prove that triangle ABC is similar to triangle RPQ. And thereafter, you need to determine the values of X, Y. So you need to first prove that triangle ABC is similar. Look at the sign there. You need to prove that the two triangles are similar. You've got a small triangle ABC followed by the bigger triangle RPQ. Of course, you are given the side AB. What is the side AB? It's given by 4. The length of that AB is 4 units. And of course, RQ, the length there is 15. You are also given BC as well as PQ. Can we prove that triangle ABC is similar? Yes, Sacha, your hand is up. Let's go to Sacha. Yes, Sacha. Can you proceed? Can you hear me? Right. Without any waste of time, we can see that we are also given angles. If you look at the angles there are exactly 2 pairs of angles there, which are equal. The first angle is A. You can see there's a star there inside the A. Angle A is equal to angle R. So in the first triangle, which is ABC, we can see that angle A is equal to angle R. And of course, angle B is equal to angle P. Sacha, your hand is up again. You want to talk about one of this? You want to prove?
Yeah. So can you hear me, sir?
Yes, definitely.
So a triangle ABC is AB is 4, BC is 3. So that means AC will be 5.
Okay.
So both of the triangles are similar because all of the lengths are times by 3.
All right. So all of the lengths are multiplied by 3. Okay, but how do you know? How do you know we have to multiply the bigger triangle's length by 3?
So because if you multiply 3 by 3, it's going to give you 9. And you're going to multiply 5 by 5, it's going to give you 15. So
Okay.
y is going to be 12.
Well, I agree with you. I agree with you, but remember, you cannot just do that by inspection. You need to give the reason.
Yes.
You can only make a conclusion once you can only make this conclusion once you have proved that triangle ABC is similar to triangle RPQ. At this stage, we have not yet proved. We need to start by proving that A is similar to triangle RPQ. Can we start there before we because what you have done now, you have just answered B. You've just given me the answer for B. I agree with you. The answer is correct. The answers are correct. But
yes, sir.
You need to base that on a reason. So, in other words, before you can determine the values of X and Y, you need to first prove that triangle ABC is similar to triangle RPQ. Can you prove that? Or can I give it to another one?
So you can give it to another person, sir.
Okay, thank you very much. But thanks once again for doing number B. Now, can we prove similarity there in the two triangles? So I can prove them for you. I want to give it back to you again as students from various corners of our land, just to prove that triangle ABC is similar to triangle RPQ. Let's engage. Lena Center. Yes.
Sir, might I explain?
Yes, please explain.
It is given that angle A is equal to angle R, and also given that angle B is equal to angle P. So we conclude that angle C is also the same as angle Q.
Exactly. Exactly. I agree with you. So you have just said that angle A is equal to angle R and angle B is equal to angle P. That's correct. That is information that is given. So you can conclude, yes. The other reason that you can put in your conclusion, you should know at this point that the sum of the angles of a triangle is equal to 180 degrees. Now, if you add A and B and C, they should give you 180. Similarly, if you add R, P, and Q, they should give you 180. And you can see that once you solve your simultaneous equation, you should be able to prove that C is equal to Q. And therefore, once you have proved that C is equal to Q, what can you conclude? What can be your conclusion? Now that
the triangles are similar.
That the triangles are similar. And what is the reason? Give me the reason for saying the two triangles are similar. What will be your reason now?
I would say all the angles are the same.
Exactly. You will say all the angles are in fact, if you want to put it mathematically, you can say equi-angular. Equi-angular in bracket. The equi comes from equal. So the term equi there comes from equal, meaning that there are pairs of angles which are equal, and you have already mentioned them. You said angle A is equal to angle R. That's the first set. The second one, you have also said angle B is equal to angle P. And the last one, of course, angle C is equal to angle Q. So you've got three pairs of angles which are equal. Therefore, the two triangles are similar because they are equiangular. So as you can see, it's the solution there, B is equal to P. Those are given angles as well as A. Pardon me for not putting the cap on top of the B there, but B meaning angle B, and P also meaning angle P, and of course angle A and angle R. And like I've just indicated now, if you add all of them, if you add the three angles A plus B plus C, they give you 180 degrees. Same goes for the P plus Q plus R. And of course, the conclusion that you can make is that therefore C is equal to Q, then it follows that triangle ABC is similar to triangle RPQ. The reason being they are equiangular. You can see that in the bracket. So we have now proved that triangle ABC is similar to triangle RPQ. Let's go to the next one. Number 2, where you are given the line AE and BD, the two straight lines. You are given the two straight lines there. You need to determine now the values of. Okay, before we go there, let's go to B, 1B. Let's determine the values of X and Y. I want you to tell me how do you determine the value without inspecting, not just by inspection, but by using the proper formula for proportion. I taught you about proportion yesterday. That is the second condition. Can someone tell us how do you find X and Y? Right? Let's see. Yes.
We would say that 7, because A and C are proportionate and D and C are proportionate, 5 and 10 would be proportionate also, and 5 divided by 10 would be 2. So we can conclude that 7 is equal to 4, X is equal to 14 and Y is equal to 5. No, 3.
Okay. And do you remember the formula for proportion?
Yeah.
So the first one you say AB divided by, you're going to divide AB by what? By RP.
AB would be DE. Yeah.
Also, you're saying AB would be equal to?
D over E.
Or D over E. I don't think that. Are you still in 1B or are you already in number 2?
Number 2.
Okay, well, I was asking about 1B. I wanted the formula to
Okay.
I know Sacha has already answered X and Y, but I want you to give me the formula. How do you determine those values? Using the functions proportionally. Right. Okay. I just want us to finish that first before we go to 2. So to determine the values of X and Y, this is how you are going to determine the values. You have your diagram there. And of course, we already know that triangle ABC is similar to triangle RPQ. This is the information that we have just proved. And of course, yesterday I taught you about the two triangles having to be proportionate. Now that we have proved similarity between the two triangles, our conclusion will be that AB over RP is going to be equal to BC over PQ. which in turn will be equal to AC over RQ. This is what I taught you yesterday. And of course, you can see that AB is equal to 4 and RP is 1. And of course, this is equal to BC is equal to 3, that is given. PQ is also given as 9. And of course, AC is X, which is now an unknown, and RQ is 50. So therefore, you can see, as such as said initially, then you can conclude that the value of X will be equal to 5, and Y will be equal to 12.
So sorry, sir, I can't see what you're explaining there, sir.
All right. Can you see the? All right. I've just increased the form. Can you see now?
Yes, sir, I can see now. I can see now.
It's visible now.
Yes, sir.
Okay, thank you very much. I was just saying that we need to determine the values of X and Y. And now we know that once you have proved that the two triangles are similar, then it follows that AB over RP is equal to BC over PQ. In the same note, AC over RQ. Then, of course, AB is 4, and then you substitute AB with 4, that is given. Then RP is 1. Then you also substitute that with 1. And this is equal to 3 over 9, because BC is 3, PQ is 9. And then AC is X, as you can see in the diagram, and RQ is 50. Then once you solve this equation, but it should be clear, you know, if you look at the second one, the middle one, 3 over 9. Can you see that? 3 over 9, the one in the center. You can see that your numerator is 3 and your denominator is 9. Now, in order to get to 9, what did you do to the numerator? This means that you have multiplied 3 by 3 to get to 9. So now that you know that you have multiplied 3 by 3 to get to 9, then you do the same. You know that in order to get the denominator, you multiply by 3. And in order to get the numerator, you divide by 3. So 4 multiplied by 3 will give you 12. Hence, Y is equal to 12. And the last part, 15 divided by 3 will give you 5. Therefore, X is equal to 5. So that was the first one that I wanted us to talk about. Of course, let me go back now to the previous one, where we need to now do number 2 quickly, 2A and B. In 2 there, you need to prove that triangle ABC is similar to triangle EDC in the second pair of triangles. Let's prove that. Let's quickly prove the 2. Let's prove, yes, King, I see your hand. Right. Let us prove that given AE and BD, which are straight lines, and you can see that we also have a set of parallel lines there. There are 2 parallel lines. Can we prove that triangle ABC is similar to EDC? Yes? I see some hands. Let's go to the next one. Of course, let's choose Kevin. Kevin? Kevin, can you hear us? Let's try Neo then. Neo, can you prove that triangle ABC is similar to triangle EDC using the information that is given? Okay, Togozo is the last one now. I'm just going to recognize the Togozo. Togozo, your hand is up. Please go ahead. Togozo? Yes, please go ahead, Togozo.
Which lines?
Come again. All right, Togozo, we seem to have lost you there. Right, basically, all that you need to do is to look at your sides, the given sides, as well as the angles.
Sir?
In this case, yes, Kevin, is that Kevin?
No, sir, it's king.
Okay.
So what's the formula for proportion?
The
Yeah.
proportion.
Yeah.
You know, you can only use that once you have concluded, once you have proved similarity. For example, let me take you back to the formula for proportion just to recap. If you look at this example here, which we have done yesterday, we said that you need to prove that triangle ABC is similar to triangle DEF. Now, you can see proportion BC over EF. You can see that those sides, you know, they are in proportion. BC's value is 90, and EF in the second triangle is 30. In the same note, AC in the bigger triangle, as well as DF in the smaller triangle, they are in proportion. And the last one, AB, and then DE. You can see that the two lines are in proportion. The green line, the red, and the purple one. I'm sure you can see that. This simply means that your small triangle there, which is DEF, it was enlarged by a factor of 3. What does this mean? This means DE was multiplied by 3 to get AB, as you can see. And the green one, DF, was also multiplied by 3 to get to AC. So 20 multiplied by 3 is 60. So the two triangles are in proportion. And the last one, EF, which was 30, was also multiplied by 90 to get, it was also multiplied by 3, sorry, to get to 90. And of course, the two are in proportion. So if you want to then get another definition of proportion, you can see the previous one there. The previous triangle, example here, we were able to prove that the two triangles are similar. And, you know, we made use of different angles there. You can see angle A and B, angle B and C, and angle E1 and we have proved there. And after proving, then you go to proportion. What do you conclude? You say AB divided by DC. You can see in the first triangle AB, then in the second triangle DC. They must be in proportion. And then in the same note, AE over DE. And this must be equal to BE over CE. Those are in proportion. So today, the first thing before you can go to proportion, you need to first prove a similarity. And now, without any waste of time, let's prove. Let's look at angle C1. I'm sure you will agree with me that angle C1 is equal to angle C2. What is the reason? The reason being the two angles are vertically opposite angles. Do you agree with me? C1 and C2. Those two angles are equal. And of course, the next one, since the two lines are parallel there, we can see that line AB is parallel to the line, the line DE. Yes, the line DE. And you can conclude again that angle B is equal to angle D, and lastly, angle A will be equal to angle E. Then the two triangles are similar. So you have proved that triangle ABC is similar to triangle ABC. Just given the following work, which we have done. This was the first one. And of course, the second one is that we have said that C1 is equal to C2. And of course, those are vertically opposite angles. B is equal to D, alternate angles, because AB is parallel to DE. A is equal to E, lastly, also alternate angles. And then, of course, you can therefore conclude that the two triangles are equiangular. And this was the work that I gave yesterday. As well, you can use the formula now to show that they are in proportion.
Sir,
Yes,
in a test, how much marks should this count for? A full thing.
then you mean both of them. They can count 10 marks.
Yes, sir.
Yes, about 10 marks.
10.
Yes, the two of them, one
Yes,
and 10. Yes, 5 each. Right. Today, I want us to take it a little bit a step further. Now we are given the, we need to determine the length of the unknown sides. We are now given that triangle ABC is similar to triangle PQR. Now, the information is given to us. What do we need? We need to determine the length now of the unknown sides. And how do we find the unknown sides? The unknown sides will be Y in the first triangle and X in the second triangle. And of course, your starting point will be that since triangle ABC is similar to triangle PQR, and that is the given information. Therefore, AB over PQ is equal to BC over QR, which in turn will be equal to AC over PR. So you work with all the sides. So the first side must be in proportion with the second. So the corresponding sides are in proportion. And what is the value of AB? The value of AB is 30, then you substitute. And the value of PQ is 60. So you have 30 over 60 is equal to, and then BC, as you can see, is Y. So that's an unknown divided by QR, and QR is 80. And this in turn is equal to AC is 25, and PR is X. From this point, you can now solve for Y. And then, of course, what has happened here? 30 over 60 is the same as 1 over 2. How do you find it? Because 30 into 30 goes how many times? It goes once. And into 60, twice. That is why you've got Y over 80 there equal to 1 over 2. And of course, you can multiply out the left hand side by 80 and the right hand side by 2, both sides. Whatever you do in the left hand side must be done in the left hand side, in the right hand side as well. Now the value of Y is 40 and the value of X would be 50 at this point. Now, the next one. The next triangle. But basically, yes.
So for the previous slide, isn't it Pythag?
Come again.
So the previous slide, the
Yes.
first slide, that you showed,
Demon.
isn't it Pythag?
Are you talking about this slide?
It's not a right angle triangle.
No, it's not. It's not a right angle triangle. It's just a normal triangle. It's not a right angle triangle. There's no 90 degrees there. So our focus now was on the sides, which are in proportion.
I'm talking about the first slide, sir.
The first slide.
Yes, sir. At around 8, I saw that the first slide, it showed the angles and they had to solve for X or Y. Isn't that Pythag? Because usually in Pythag, you had to solve for X or Y.
Oh, Pythagoras. Okay. Which slide are you talking about?
The first one, at around 8 o'clock, you were showing that.
Okay. Let's go back. You'll tell me where to stop. I'm now in the slides. This is where I started. I started with the slide showing the beds, and then I explained similar triangles, which we explained yesterday. This was the second slide. So the first slide basically was this.
Okay.
Similar triangles, and of course, I proceeded to find a similarity. And this is the work that we did yesterday. It was just to recap. Now I showed you these two triangles. So
Okay, for this slide, sir, for this side, isn't this Pythag because you usually solve for X?
But there's no right.
If you have
There's no
You
right
use theorem
angle.
of Pythagoras when it's a right angle triangle.
exactly. When it is a right
Oh.
triangle, yes, you can use Pythagoras. Definitely. If it's a right angle triangle, you can use Pythagoras. I agree with you. But at this stage, these are just triangles, no angle. Okay.
Okay. Thank you, sir.
Right. Now let's carry on now to the next activity. We have how many triangles there? We've got two triangles there. Triangle ABC and triangle ADE. I want us to prove that the two triangles are similar. Now, in order to show that the triangle ABC is similar to ADE, you need to use the different triangles and different colors. You can see that, this triangle ADE and ABC are in the same, they are on top of each other. So you need to separate them, meaning that you must draw ADE separately and also draw ABC separately. And once you have done that, you will be able to see that you can be able to now compare the two triangles. You will have a separate triangle, which is ADE. You'll also have a separate one, ABC. So I want you to first separate the triangles. So you can draw it on the side and have two separate triangles, ADE and ADE. I hope that you have done that now. Now you've got two triangles. So you've got two triangles not attached to each other. Now, the first thing that you'll have to do, you will see that angle A appears in both triangles. Meaning that you will say angle A, which is in triangle ABC, is equal to angle A, which is in triangle ADE. So remember, you have two triangles. So what is the reason for that? That is a common angle. The angle is common in both triangles. Thereafter, you will say angle B is equal to angle D1. Why are they equal? They are corresponding angles. Why are they corresponding? Because you can see the line, the arrows there. DE, the line DE is parallel to the line. Therefore, angle B is equal to angle D1. And in the same note, angle C will be equal to E1. Again, the two are corresponding angles. You can see that they are corresponding because the line DE is parallel to the line BC. DE and BC are parallel. Thereafter, you can conclude now that you have proved that all angles are equal. Then you can conclude that triangle ABC is similar to triangle ADE. What is the reason? Angle, angle, angle. Or you can say equiangular. If you want to put it differently, you can say equiangular. The three angles, the three pairs of angles in each triangle are equal. Then you need to now determine the value of x. Again, you have separated your triangles. It should be clear at this point that if the two triangles are similar, then you must also use proportion. You can say that AC over AD is equal to BC over DE, which in turn is equal to AC over AE. And you can see that AB is 6, that is given, and AD is 4, then you substitute. BC is 12, DE is 8. And then AC, can you see AC in the bigger triangle, where the original triangle? AC is made up of AE plus EC. And AE is given as X and EC is 3. That is why you have X plus 3. Divided by AE, and the value of AE there is unknown, which is X. Then thereafter, you can use, you can simplify your equation by solving for X. And of course,
Sorry to ask, sir.
Yes.
Sir, why do we divide here?
That is proportion. We said yesterday that when the two triangles are similar, then the corresponding sides of those triangles are in proportion. This means
Okay.
you can take one side of the first triangle and divide it by its corresponding side of the second triangle. And once you do that, you can equate it to the next side of the first triangle, which is in turn is divided by its corresponding side of the second triangle. And of course, you do the same with the third side. With the third side, and the third side as well, you divide it by its corresponding side in the second triangle. That is what we call proportion.
Okay, thank you, sir.
Yes, it only follows once you have proved that the two triangles are similar, then you can conclude that the corresponding sides are proportional. Yes?
Hello,
Yes, I can hear you.
sir, can you hear me?
Yes, I can hear you. Please go ahead.
Sir, you two first, can you please explain a bit slower?
Thank you very much indeed. I'm going to explain slower. I'm saying that as we discussed yesterday, similar triangles, it should be clear at this point that in order for you to prove that the two triangles are similar, you need to look at the angles first. Now, once you have found that the angles are equal, meaning that the corresponding angles, the pairs of angles from the first triangle to the second, like in this case, you've got A, which is common. You also have B, which is equal to D1. And of course, you've got C, which is equal to E1 as well. Once you have proved similarity, then you can conclude that the corresponding sides of the two triangles are in proportion. And what does this mean? What do we mean when we say they're in proportion? It simply means that you have enlarged one of the triangles in order to get to the next triangle, or you have reduced one of the triangles in order to get to the next triangle. So if you increase a side, only one side by 2, meaning that if AB, for example, is 2 centimeters, and then EF is 4, this means that you have multiplied, to get to EF, you have multiplied by 2. So all the sides have to be multiplied by exactly the same number. So meaning that they will be in proportion. Now, it follows that from this example here that AB divided by AD will be equal to BC divided by DE, and which in turn will be equal to AC over AE. And you can only see this once you have separated your triangles. It's very important. Please take note, you need to separate the triangles. Just as we have shown you with the beds, the example of the beds in the beginning, they are separated. You can't keep them, you can't keep one on top of the other. You must separate them in order to see the similarity, in order to prove that they are similar. You must have one picture on the other side and the picture on the other. Choose and observe them independent of each other. And of course, the value of x in this case will be 6. Now, in the following activity, one of the triangles is not similar to the other two. I wanted to prove that the two triangles are similar in each case. The first things first, how do you prove similarity? You need to have all the angles. So there's a missing angle in each triangle. I want you to find that missing angle. As you can see in A, we have 3 triangles there. Triangle ABC, triangle PQR, and triangle XYZ. Now, you are also given the set of angles there. So for you to prove that the two triangles are similar, you have to have the same equal angles, pairs of equal angles. Now, how do you prove this? You need to find the missing angle. For example, find C, find Q, and find Z. So in the first triangle, you find C. In the second triangle, you find Q, the value of Q. In the third triangle, you find the value of Z. And what are you going to use? You can use the principle that the sum of the angles of a triangle is equal to 180 degrees. So I'm sure that you should be able to find the missing angles. And that will guide you. Let's do the first one together now before we can proceed. Let's do the first one now. I just want you to find the missing angles, or just tell me, you can tell me which triangles are similar. Between ABC, PQR, and XYZ. Let's go to, yes, carry on. Which triangles are similar?
So triangle ABC and QPR.
So you say ABC is similar to PQR.
Yes,
And what's the reason for that?
because they are equiangular.
Okay, what do you mean they're equiangular? Give me those the angles that are equal. The pairs of angles that are equal.
Angle B and angle P is equal. Angle
B
A and angle R
yes,
is
definitely.
equal. And if you
and C?
subtract both those numbers from 180 degrees, you'll get angle C and Q.
Exactly. So I fully agree with you. Angle ABC is similar to triangle QR. In the sense that when you add your two angles, 68 and 37, and you subtract that from 180, you should be able to get the same angle. Q and C will be equal.
Yes, sir.
Let's go to B quickly. Which triangles are similar?
Triangle ABC and triangle XYZ.
Why do you say so?
How?
Because triangle A is corresponding to triangle Z and triangle B is corresponding to triangle Y. No.
Okay, you're talking about the angles now. Okay, you said angle A is equal to angle Z. I fully agree with you on that one. What about the other angles?
Oh.
So let me give you
They're
a
not
hint.
corresponding.
All right, can I give you a hint?
Yes, please.
You need to find you need to use the principle of 180 degrees. You know, three angles form 180 to find the missing angle. In other words, you need to find angle C. You need to calculate C first and then find the value there. How do you calculate C? You will add
You can
56
say
and
angle A
48.
plus B plus C. Yes.
Yes, and then you add 56 and 48. You subtract the sum from 180, and then that will give you C. You do the same with angle P, Q, and R, and you also do the same with X, Y, and Z. At that point, you will see the structure.
So
Yes.
triangle ABC is equal to triangle XYZ because
Right, so,
angle A is corresponding to angle Z and angle
Okay.
B is corresponding to angle X
okay. And
and
angle
angle C is corresponding to angle Y.
Yes. So did you calculate C? What, did you find the value for C there?
Yes, sir.
What is the value?
76 degrees.
76. Yes. How did you find it?
So I said A plus B plus C is going to equal to 180 degrees. Then I
Okay.
took the values. Then I said 48 plus 56 plus C is going to equal to 180 degrees. Then I added those two, which gave me 104. And then I subtracted 104 from 180.
Yes.
180 from 104.
Definitely. Definitely. Yes. I fully agree with you. So triangle ABC will be similar to triangle XYZ. So like I said initially, the most important thing is to find the missing angles so that you can be able to make the correct comparison. Now, I realize that time is not on our side. I want to give you this work as part of your homework. Just carry on from C and then D and E. Just prove that two triangles there are similar by using the next one. Now you use the sum.
Sir,
You use proportion in the initial one. Yes.
sir,
Yes, go ahead.
sir, for the last one, number C, are we supposed to use Pythagoras to find the right
No.
value of?
No, you use proportion. You use proportion.
Okay.
Yo,
And
sir.
of course, you do the same with D and E. And I also have just last one year. I hope that I was not fast. Did you manage to get all the slides? The homework?
No, sir. Can you please go back?
All right, let me go back and do the original one. This is C. I'm done here. Can I move to D? The picture there.
Sir, is it C to E?
Yes, C to E.
So you can move.
So let me move now to the next one, which was your homework. And of course, this is 1A, B, and C. 1A, B, and C. And this is for, you know, battles ahead, as I've already indicated, so that you don't fall behind in as far as and of course, visit some of the links which I've shared with you. Let me invite you to our next which will go 3248. Alternatively, go to our Facebook account, Africa Teen Geeks.
Sir,
Also,
do you mind
on
going
Twitter
back to
account at Africa Teen Geeks. And of course, make use of the DBE website as well. Until we meet next
Yo,
week,
sir.
have a good weekend. Thank you very much indeed.
Thank you, sir. Bless your heart.